Good afternoon. In here, we will present about our robot. It's called Building Window Cleaner Robot. Previously, let me introduce my team. My name is Jhon, I'm the leader of this team. And then as a electrical, and then Diyna Afrina as a electrical, Enno Nurwansyah as a programmer, Najla Eirba MSc as a programmer, Husnan Nadzori as a mechanical, and the last is Alya Mufidah as a mechanical.
Problem statement. Cleaning the windows of tall buildings in polypattern is very dangerous if done manually. However, if not cleaned, that will accumulation on the glass windows. Therefore, a window cleaning robot is needed. This robot can clean the surface automatically, efficiently, and controllably, as well help reduce the risk of accident.
System requirement review. This window cleaning robot is designed based on function, safety, and user need. First, from the function side, the robot can clean glass and move up, down, left, and right instant away. The robot has a rope and pulley system to reference pulling, and it can be controlled using an application. The robot can also stop safely during emergency conditions. Secondly, from the mechanical side, the robot frame is light but strong, so it doesn't not damage the glass. The, the wheel, tray, and pulley system works in the correct position to keep the robot movement stable. The cleaning material is safe from the glass surface. Third, from the electrical side, the robot uses ESP8266 as a main controller, DC motor, and motor driver as are chosen based on speed and power need. The power supply is stable and the wiring is safe to avoid short circuit. Next, from the control software requirement, the system can control motor, direction, and speed well. The user interface is simple and easy to use. The program can handle normal condition and emergency situation, and it is easy to improve in the future. For safety, the robot is designed to protect the user in the working area. The system doesn't damage the glass and has a safety mechanism that still works when a problem happens. The design also follow safety rules from working at height. Finally, for non-functional needs, the robot is easy to maintain and repair, use energy efficiently, and has a low cost. So it is suitable as an academic prototype.
Concept of this project is to design a safe, practical, and easy to control window cleaning robot for high-rise building. The robot uses a semi-automatic system allowing user to manually control its movement and cleaning process through an application, giving full control during operation. This project was developed to address common problems such as the risk of falling, time-consuming cleaning process, and the limitation of conventional window cleaning tools. Therefore, the robot is designed to move on glass surface equipped with a wrap and pulley safety system and capable of control vertical and horizontal movement. Implement system concept is first a mechanical system using a lightweight frame, wheel, rail, and pulley mechanism. electrical system using an ESP8266 microcontroller, DC motor, motor drivers, and a stable power supply. A control system using the blink application to manage motor speed and direction. And safety system to prevent falling and minimize risk to user and glass surface.
I will I will be explain preliminary design review. The initial design of the window cleaning robot is based on a semi-automatic robot concept that is safe, lightweight, and easy to control. This design aims to meet the system requirements, especially in terms of functionality, safety, and ease of operation. First, mechanical design: a lightweight and strong frame with acrylic or aluminum with a compact and balanced shape. Horizontal movement using wheels or rails, and vertical movement using a pulley system and safety rope. Use microfiber cloth or sponge to avoid damaging the glass. Second, system integration. The Blink application sends commands to the microcontroller via Wi-Fi. The microcontroller controls the motor for horizontal and vertical movement. The system is designed to meet functional, safety, and cost efficiency requirements as an early prototype. The third, hardware electrical design. Use ESP8266 and the AAS main control with Wi-Fi connection. DC motors are controlled by an L298N motor driver using PWM signals. Power is supplied by a DC battery with a voltage regulator for stable power.
Now about the critical design review. We have technical feasibility and fabrication. The design is considered feasible to fabricate using standard parts and simple tools. Has suitable functionality and performance, and is reliable enough for repeating the test at the prototype level. For the safety, quality, and ergonomics, the system meets safety requirements with a fail-safe protection mechanism, safe opponent placement, compliance, performance. About draft design document and final design. As we can see, we use triplex, woods, and can. For the building, we use some triplex and woods. And for the track, we use stainless steel, two stainless steels. And for the pulley, we use can with combined by the robots, by the woods of robots. That's the design. In here, I will explain about the final electrical design of our robot. The first, some of components that we use, it's like one ESP8266, two motor driver L298N, two DC gearbox motor, one DC motor, step down XL4015, one breadboard, one switch button, and the last is four lithium batteries. Okay, the second I will explain about the electrical circuit diagram about our robots. So, first, the current flow from the 16-volt battery to the switch button, which connect and disconnect the power supply. After that, the current is divided into two paths, one for motor drivers and one for motor step down. The current into the motor driver is gonna enter through 12-pin volt, and the current will be stuck until the ESP send the command signal. And then in the motor driver, the current is directed by each bridge chip. For example, if the ESP send command signal forward, the current will be flow from 12-volt pin to out1 pin through the motor wing links and back to out2 and then back to grounding. When current pass through the motor driver, the voltage drop may be around 2 volts because the characteristic of its internal components. Maybe if the battery is 16 volt, it's gonna be maybe just 14 volt that enter to motor driver. And then for motor step down, the current's gonna flow enter through in plus and then will be reduced around 3 volt and then gonna flow to out plus and then to 3 volt pin in ESP. So when ESP send common signal to in 1, in 2, in 3 or in 4, pins on motor driver will be open to power flow gate and then all of grounding from motor step down, ESP and motor driver is gonna be connect to negative.
Okay, I will explain design flowchart, document, and final design. This flowchart is explain how the robot system works using the Blink application. After the system starts and connect to Wi-Fi, the robots receive from input from the joystick and buttons. The joystick controls to the DC motor movement forward and backward, while the buttons control motor for rotation. If there is no input, the motor will be stopped.
Job desk, the first, Jhon Siburian, responsible for hardware and electrical design, include design the electrical circuit, mapping ESP A266 pin to the L298 and motor driver and DC motor, and creating the system flowchart and wiring diagram. The second, Enno Nurwansyah recipe, works on electrical system and control, including prepare the component list, assembling the electrical system, simulation, roll, and full movement, and integrating the control system with hardware. And Diyna Afrina focus on software algorithm develop, including create program logic and design the system workflow from initialization to setup. And then Husnan Nadzori, responsible for mechanical design and prototype develop, including design the robot structure, revising the prototype, and determining component size and placement. And then Najla Eirba, responsible as the system analysis, focusing on identification problem in the glass cleaning robot related to safety, efficiency, and working time. Also prepares the problem statement, system requirement, review, and concept project documentation. Alya Mufidah, responsible for the cleaning system, including study the cleaning, fluid spraying mechanism, design the hose and nozzle system, and integrating the cleaning system with the robot mechanism.
Okay, now in here, I will explain about project evaluation for our robot. Shortcoming and areas for improvement in this project. The window cleaner robot project has been successfully built as an initial prototype, but it still has several weaknesses. The motion system still works suddenly, which causes jerking and swinging movement that can reduce stability and safety. The motor speed control doesn't yet use gradual acceleration and deceleration, so the robot movement is not smooth. In addition, motor performance data has not been collected and recorded in a structured way, which makes system analysis limited. From the mechanical side, the design is suitable for a small scale prototype, but it's not yet optimal for a larger scale because the stability of the pulley and rope system is not fully maintained. In the future, this project needs further development, especially in speed control, mechanical design, and database evaluation, so the robot can operate more stably, safely, and be ready for future development. Okay, that's all that we can give to present. Thank you so much.